Some classes, such as our student class we created and our square class created, explicitly extend other classes. For example, student extended person, meanwhile square extended rectangle, and then circle extended oval. However, other classes don't explicitly extend another class. So for example, person extends what? Rectangle extends what? Oval extends what? And even, for example, string extends what? It turns out every class that doesn't explicitly extend something else extends the universal superclass object. Now, what is the object class? So first, the object class has no instance variables, and then it has an empty constructor. So for example, like that. That's how I create an object. And by default, when I print it, it's useless. What usefulness does object provide? So there's several of them. So first of all, we have that just like student and person or like square and rectangle, we can do like object O2 equals, for example, a string. Object O3 equals, say, another string. And then let's just say we create a random class here. Object O4 equals new A. And all of that would work. You could also pull our square, rectangle, student and person classes right here from last time. And then we get that, for example, object O5 equals new rectangle, 5, 7 works, and object O6 equals new square, 6 works. Notice that square does not directly extend object, however square extends rectangle, and then rectangle extends object. So then, therefore, square indirectly extends object, so this still works. Now, stuff that you're not allowed to do would be, for example, square O7 equals new object. For the same reason you can't do square S1 equals new rectangle. So then, for example, we can create object arrays that contain basically various different objects that can have no relation to each other. For example, like that. And it'll work because all of these either directly or indirectly extend the object, except for this object, but it is an object, so that works also. So that's one usefulness of object. Now, what happens if we do, for example, that? Of course, we can fill this array with objects. For example, OAR2 of 0 equals, say, new person, like that. And it'll work. However, what about the other ones that I haven't filled in? So for example, like that. It turns out it'll be null. We've went over this briefly before, but basically what is null? So null is basically something that basically means no object. Basically, null basically means that, so for example, we can have a variable right here. If we set it to null, that means that it's actually, even though str is supposed to have something of type string, we couldn't find one, so we're going to make it null. That's what null means. And it turns out if we try to do anything with null, so first of all, if we just try to print it, it's just going to print null, just like the other null object. If we do str plus str like that, it'll compile, and actually in this case, it'll actually just print null. However, if I try to access a method or a variable of our null object, so for example, str dot say length, which is just returns the length of the string, that'll compile when I run. However, it'll cause a runtime error called null pointer exception, where I basically have a null and I'm trying to access a length, which doesn't make sense because there is no object to begin with. And the reason it gets past the compiler is because str is of a type string. String has a length, and the compiler has no way of knowing whether str is null or not. Another example, rectangle r1 equals null. In this case, we cannot do, for example, r1.area. If we do that, it'll compile, but when we run, it'll cause a null pointer exception. We can't print r1.length. If we do that, it'll compile, but again, null pointer exception when ran. Now, how do we avoid those? Well, it turns out you can check whether something equals null just using this equals sign. So if r1 equals null, then I don't do anything. Or a better way would probably be, if r1 doesn't equal null, then for example, print r1.area. So then, for example, in this case, it won't do anything because r1 is null, so this is false. However, if I introduce, like, for example, right before the if statement, I introduce something like r1 equals new rectangle 2, 3, it'll print 6.0, as shown below. Now, similar to arrays, uninitialized instance or static variables will be null. So for example, string str1, if I print str1, it'll be null. And if I try to access a method or variable, then it'll cause an error. Notice that we need a static right here, and the reason we need that is because if we just make something like this, notice outside the main method, then since it's not static, it would be an instance variable, and if it's an instance variable, we can't directly print it in from a static method. We would need to do something like new, say, level 3, lesson 1, part 3 dot str2. And either way, it's going to be null. And we can't access anything like length, because then it's just going to cause an error. What happens if we do the same thing inside of the method? So for example, string str3, and then we try to print it. Remember, now str3 is a local variable, and as we went over before, you cannot print or access basically an uninitialized or potentially uninitialized local variable unless you're initializing it. So basically, variable str3 might not have been initialized. This is where null comes into play. So basically, we can set str4 to say null, for example, and now I can print str4. It's just gonna print null, and I can't access str4.length or anything like that, but it's better than a compilation error sometimes, particularly since we can do, for example, if str4 is not equal to null, then we do the following right here. And we can even do like dot length, because we know here it's null, so it's not going to print the dot length. But if it's not null, then it's going to print the length. On the other hand, for str3, if we try that, if str3 is not equal to null, then do the same thing. It's not going to work because str3 again may not have been initialized. We can't access it unless we're initializing it. Another thing you need to know about null is that null is an object type. So basically, for example, we cannot set a primitive data type variable to say null. That's just not allowed. Now let's go back to our object class right here. So currently our object class has uses. For example, we can put different various objects in an array. We could also have a method that takes in an object and therefore can take in like various different objects. Now, another use of object is the methods it contains. So, the class object contains so far at least 2 useful methods we can use. Basically, the first one is the toString method, and the second one is the equals method. Both of them are instance methods. So basically, what is the toString method? Returns a string basically that should usually represent what the object is about. And the equals method, which takes in an object and returns whether the object is equal to the parameter. So first we'll go over the toString method. So by default, if we have an object right here, what is its toString method going to return? Again, just like if we were to print it directly, the toString method returns some useless information. Now, why is toString useful then if by default it just returns useless information? Well, this is where inheritance comes into play. Every class extends objects either directly or indirectly, which means that a class, for example, rectangle, extends object. So therefore rectangle inherits the toString method. Now again, of course, rectangle, if we make one and then print the toString, then we'll get this useless information just as if we were to directly print it. So then, why is toString useful? Well, it's useful because we can override the toString method. So now, public string toString. So this is overriding the toString method. Return, say, length plus x plus width. And now, the rectangle's toString method is going to return useful information. Now, the question of why do we need object to have the toString method? Well, now, since object has a toString method, we know that every single class has a toString method. Therefore, the print method can be programmed, like system.out.println can be programmed so that whenever I print an object itself, it actually prints the thing.toString. So actually, the nice thing about toString is that you don't even have to call it. Basically, now that I have a toString method, I can directly print rectangles. So system.out.println R2, it works. Similarly, square, SQ, like this. I can directly print the square because, again, square extends rectangle, meaning that the square class inherits the rectangle's toString method. And I didn't override it, so it's just going to be 5 by 5 in this case. We can do the same thing for, say, person or student. For example, for person, public string to string. It would be kind of like the display method, except there's no print statements. So like, for example, here, you could do something like return name plus name plus new line, year of birth, and so on. But this can sometimes get long and sometimes disorganized. Another way of doing this is to keep track of the result. Let's say it starts off with the name, like that, and then result plus equals, say, year of birth. Right, new line, then year of birth, plus year of birth. And then result plus equals new line, email, email. And then result plus equals new line, phone number, plus phone number. And then return result. That's another way you can do it. And now, for example, we define the person object right here. So for example, we can print this thing. If we just do system.out.print that thing, then it's going to print this. And notice that there is no new line at the end. I could just choose to do a new line at the end, but in this case, I decided to not do so because when I print ln, it's going to have the new line anyway. It's your choice whether you want a new line at the end of a toString method. Usually though, if something can be displayed in one line, the toString method should not have a new line. And then again, just like the display method, for student, in order to have all information, we may need to override the toString method. So again, public string toString. String result equals super.toString. Remember, we can do that. So now we don't have to copy all of that. And now we just do like result plus equals new line, grade, result plus equals the GPA information, and return result. And then we can print students all of a sudden. Like that, and now when we print it, it's gonna work because we successfully overrode the toString method. And we don't need to call the toString method again because the print statement directly calls the toString method, which is the nice thing about object having a toString method. Because the print statement can directly call the toString method thanks to the fact that we know that every class has a toString method, whether or not we actually override it. Of course, if we don't override the toString method, the toString method is just going to be useless, but when we override it, we can directly print objects, which is nice. So basically, there's three main ways to print objects. The first way is to use the toString method. Second way is to use a display method that prints stuff. So toString returns a string to be printed so that we can directly print stuff. Display directly prints the items or information. One advantage of toString to display is that toString, I get to access the string And you'll learn later that we can create another string that's basically the toString method but modified slightly. Like if we want to modify something slightly, like for example add something in the middle, with the toString method we would be able to do that, but with the display method you can't do that because you already printed it. And then 3 is to print the variables directly, and however that's less efficient. Now that we've covered the toString method, what about the other one, the equals method? So why would we need an equals method when we have the equals equals? Well, let's see. First of all, the equals equals works perfectly with numbers and primitive data types. Basically, all of that works. However, when done with objects, it's slightly different. So, for example, what if we have a string str4 equals QWERTY, string str5 equals QWERTY, and then string str6 equals, say, new string QWERTY, or something like a string that's obtained another way, like user input or something like that. Or maybe str5, str6, and str7. Now, here's some questions. So str5 equals str6 right here. str6 equals str7 right here. It turns out the first one is true and the second one is false. Why is that? Well, the first one would be something like this. str5 points to QWERTY, which also str6 points to. Notice that there's no new keyword, so there's really no new object. And then str7 points to another QWERTY. So they're different objects. And in general, the equals equals compares whether two objects are like two variables or expressions are point to literally the same object. So equals equals doesn't actually compare values for non-primitive data types. And that can be a problem because, say, string comparison is a very basic thing. However, the equals equals is not necessarily going to always work there. Well, how do I solve that? Well, there's something called an equals method. So basically now str5.equals str6. That's going to be true. str6.equals str7. That's also going to be true, even though they're not the same object, because they have the same value, which is what equals is supposed to compare. And then say QWERTY dot equals str7, because remember that this QWERTY is an expression, so that evaluates to a string object, so we're allowed to do equals, and it's true. And it's all true because they're the same value. If we were to do something like QWERTY equals, it would be false. Or maybe like QWERT1, it would also be false. So in general, the equals method is supposed to compare values. So the equals method, again, is in the object class. And by default, the equals method returns true if they're literally the same object and false otherwise. So by default, it's literally equals equals. So for example, O0 dot equals O0 is true, but O0 dot equals new object is false, even though they have basically the same value. That's what equals in object does. Basically the same thing as equals equals. However, what's the usefulness of this equals method? Well, it can be overridden. In particular, string overrides the equals method to return whether the given object is equal in value to the parameter or argument, depending on how you look at it. Of course, classes that we create, like rectangle for example, don't override the equals method yet because we haven't made it override the equals method yet. So for example, rectangle R1 equals new rectangle 3.5 4.6. We make the same rectangle, except it's not really the same rectangle. 3.5 4.6, something like that. And then say rectangle RR3 equals RR1. So let's print RR1 dot equals RR2 and RR1 dot equals RR3. And it turns out it's going to be false true, as shown below. Why is the first one false? Because RR1 equals RR2 would also be false. They're not the same object. However, RR1 dot equals RR3 would be true because they're literally the same object. Now, let's say we actually wanted to compare the values. Then what would we do? Well, of course, we would need to override the equals method. And of course, the equals method returns true or false, so it's a Boolean. Equals, so this overrides. And we need to take it as a parameter an object. Notice not a rectangle, just an object. That's what the equals method in object is. And now we can do the thing. So basically, if this is basically a general procedure. If O is null, then I can return false. If O is not an instance of, basically if I pass in a string object into the equals method for rectangle, so if O is not an instance of rectangle, then I just return false because they're clearly not equal. If, and otherwise actually, I can do like cast it to a rectangle like that. And now I can return, say, length equals r dot length and width equals r dot width. Basically, for example, if both the length and the width are equal, I deem the rectangles as equal. Now it's going to be true for the two equals methods right here. Of course, if I do something like new rectangle 1, 2 dot equals RR1, it would be false because they're not the same value. And in fact, even 3.5, 2, they're not the same value because we check both the length and the width. Now here's a question. What would say new rectangle 5, 5 dot equals new square of 5 be? Well, it turns out this would also be true because, well, let's go over this again. O would be a type square, so O is not equal to null. It's literally a square. O is, again, an instance of rectangle because it's a square. So then the length and width are equal to each other. Both are 5 by 5 rectangles, so then therefore it's true. Similarly, new square of 5 dot equals. Notice that square inherits the equals method from rectangle, so this would work. New rectangle 5 comma 5. That would also work. Now, of course, if I pass in something absurd like new rectangle 6 comma 7 dot equals null, that's going to be false, obviously. If I do dot equals a string, that's going to be false, obviously, and so on. Again, if I have a null object right here, I'm allowed to do, for example, new rectangle, or even like rr1 dot equals rr4. That's just going to be false because rr4 is null, and that's what the first thing we checked, so that we didn't get a no pointer exception. However, if we print rr4 dot equals rr1, it's not going to work because rr4 is null, and null does not have an equals method. So remember, just like when using the equals or toString method, be careful. If the calling variable is null, then it'll cause an error. And otherwise, the equals method is just going to return whether the two objects are equal in value, depending on what we determine as equal in value. Of course, it doesn't have to be like length equals length and width equals width, but this is the way we defined it, and in general, we should compare, basically use the equals method to compare values we want to compare. So the rectangle case, it's probably best just to check both length and width. For person, it's probably best to check name, email, phone number, and year of birth, just to make sure. However, for student, we might not want to check grade and GPA, and the reason is because if we're comparing a person with usually like if you have the same name, email, phone number, or year of birth, but you're just a person object, you might not have a grade and GPA in your person object. But so basically, you don't have to compare all variables or instance variables, but you should compare most relevant instance variables. So basically, two objects with different value should have equals return false. But if they're the same value, where value is determined by you, then it should return true.